Hello viewers, welcome to Learn Computer PC channel. In this video, we are going to discuss about error detection code, gray code and alphanumeric code. First, we will see error detection code. When a binary information is transferred from one end to another end through a communication medium, it may be radio waves or a fiber, wires or etc. If there is an external noise in the communication medium, there is a chance of error in the data which we send from one end to another end. To detect those errors, error detection code is introduced. Here we are going to see the error detection code as parity check. Parity check is one of the error detection code. If the error occurs simultaneously, if the error occurs often, there may be a chance of malfunction in the system. So we should detect the malfunction in the system, we should rectify it. If the error doesn't occur that much often, there is no need of rectify it. We can ignore it, or we can resend the message which we sent before. Okay, first we will see the error detection code, that is parity bit. How the parity bit is used to check detect the error means, if we send a message, there will be an extra bit in the message. That parity bit is meant for number of ones in the message. It may be even or odd. The parity bit is checked for even number of ones means it is even parity. If it is checking for odd number of ones means it is odd parity. The both end, that is the sender side and sender network and receiver network, should follow the same type of parity check. If the source follows the odd parity, the destination should also follow the odd parity. If the sender network follows the even parity means the receiver side also follows the even parity. How it check means, first of all, if you want to send a message from one end to another end means, first of all, the message is sent to the parity generation network. In parity generation network, if it is a odd parity check means it checks the number of ones in the message. If the number of ones in the message is even, one is the parity bit will be 1. If the message contains odd number of ones means the parity bit will be 0 for odd parity. It will be sent to the source. The source send the message to the along with parity bit, it sends the message to the destination part. In destination part, before the destination received, it reaches the parity check network. In parity check network, it checks for the number of ones in the message. If it follows the odd parity check means it checks the number of ones in the parity is number of ones in the message is odd or even. If it is odd, then the error is there is no error. If there is a number of ones is even, then there will be an error. It detects the error and sends the message that there is a error in the message. Okay, now we will see how the parity bit is added in the message. If it is odd parity, will start from 0 to 9. 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 and 1 0 0 0 1 0 0 1. I am going to check. This is from 0 to 9 numbers. I will assume these are all the messages to be sent from source to destination. I am going to add the odd parity bit to the messages. First message is 0 0 0. There is no 1 in the message, so there should be odd number of ones in the message. So the odd parity will be 1. Here in the second message 0 0 0 1, here odd number of 1 is there, so odd parity should be 0. The next is 0 0 1 0 1, here one odd number of 1 is there, so odd parity is 0. For 0 0 1 1, there is a even number of even number of ones in the message, so we should add 1 to make this message odd number of ones. Okay. The next is 0 1 0 0. Here there is odd number of 1, that is only 1, so we should put 0. Here 2 1 is there, so to make it odd number of ones, I make it as 1 in the odd parity bit. Here even number of 1 is there, so I should put 1. Here odd number of ones, we should add 0. Next is here 1, there is odd number of 1, so I should add 0. Here even number of ones, I should add 1 to make this message odd. Okay, in even parity bit, here there is no 1. If I put 1, it will make it as odd number of ones, so I put this 0 for even parity. Here there is odd number of ones, I need even number of 1 in the message, so I make it as even number of ones. I add 1 to the message, then it becomes even number of 1 in the message. The next is here also odd number of 1, so in order to make it as even number of 1, I add even parity as 1. The next is here even number of 1 is there, so I put 0. Here odd number of 1, I put 1. Here even number of 1, I put 0. Here even number of 1s, I put 0. Here odd number of 1s, I put 1. Here odd number of 1, I put 1. Here even number of 1, I put 0. For odd parity, it indicates the message has odd number of ones. If there is even number of ones, the odd parity will be 1. If the message contains odd number of ones, the odd parity will be 0. In case of even parity, if there is an odd number of ones, the even parity is 1. If there is even number of ones in the message, the even parity is 0. That's all about error detection code. Next we will see gray code. Gray code. The gray code is used to represent the digital data which is converted from the from analog data. Actually, the analog data is represented by the physical systems. If the physical system, the output of physical system is represented in the digital system, those analog data should be converted to digital data. To represent those digital data, gray code is used. In gray code, to represent the data from one message to another message, the gray code will be differ by only one bit. Okay, we will see with the example. I will write gray code for decimal numbers from 0 to 9. For 0, I put 0, 4 zeros. For 1, I should change only one bit in the previous message as 1 or 0. I change the least bit. Here least bit is 0. So, I change this bit as 1. Then we will get the gray code for 1. The next is 2. For 2, already we have a least place 1. If we change the least place 1 as 0, it will become the gray code for 0. So, we should shift to least to the next higher position. Here higher second position we have 0. We should change this 0 as 1. 0 0 1 1. For 3, if we change the least bit as 0, 1 into 0, it will become 0 0 1 0. So, it is a new gray code. We can take it as new gray code for 3. For 4, if we change this 1, 0 to 1, it becomes 0 0 1 1. It is already there. So, we should shift to the next position. If we change this 1 as 0, it becomes 0 0 0 0, 4 zeros. It is also already there. So, we should shift to next position. The next position we have 0. We will make it as 1. 0 1 1 0. This is the new gray code. Then it is represented for 4. Again for 5, we should change any bit into 1, but we should change at only one bit. Here, if we change the last bit as 1, it becomes 0 0 0 1 1 1. It is a new code. Then we will take it as gray code for 5. Next, for 6, if we change the last bit as 0, it becomes 0 1 1 0. It is already there. So, we should shift to the next position. Here we can change this 1 as 0, the next higher position. It becomes 0 1 0 1. That is 0 1 0 1 5. So, this is a new code. So, we can take it as new code for 6. Okay. The next for 7, if we change this 1 as 0, it becomes 0 1 0 0. It is also a new code. We can take it as new code for gray code for 7. Next is 8. If we change this least significant bit as 1, it becomes 0 1 0 1. So, it is already there. We should shift to next position. 0 1, we take it as 0 as 1. 0 1 1 0, it is also already there. So, we shift to next position. If we change this 1 as 0 0 0 0 0, there it is also already there. So, we should shift to next position 0, the most significant bit. If we change the 0 as 1, it becomes 1 1 0 0 0. So, 1 1 0 0. It is also a new code. We can take it as for 8. The gray code for 8 is 1 1 0 0. Next for 9, if you change this bit as 1 1 1 0 1, it is also a new code. We can take gray code for 9 as 1 1 0 1. That's all about gray code. Next we will see alphanumeric codes. Next is alphanumeric code. Alphanumeric code is used to represent numbers, alphabets and special characters. We have some of the alphanumeric code as internal code. Internal code is 6-bit code used to represent uppercase alphabets, numbers and some special characters. It doesn't represent the lowercase alphabet, so in order to represent it, we have 7-bit code, ASCII code. American Standard Code for Information Interchange. The expansion for ASCII is American Standard Code for Information Interchange. It is a 7-bit code. It is used to represent the uppercase alphabets, numbers, special characters, etc. The next is EBCDIC code, EBCDIC. It is a 8-bit code. It is also used to represent alphabets, numbers, special characters, blank space, etc. It is a 8-bit code. The 8-bit is used to represent as parity bit. The expansion of EBCD code is extended BCD for interchange code. These are all the alphanumeric codes. Internal code is a 6-bit code which is used to represent uppercase alphabets, special characters, blank space. ASCII code is 7-bit code used to represent upper and lowercase letters, numbers, special characters, blank space. EBCD code is also used to, it is an 8-bit code. It is used to represent uppercase and lowercase alphabets, numbers and special characters. That's all about error detection code, gray code and alphanumeric codes. If you like this video, please share this video and subscribe my channel to support my channel. Thank you.